in neural network, we need to follow the neuron concept. In neurons, basically electric pulses disturb the dendrites, and dendrites provide the input to cell body, and this cell body basically provide the required output. In this case, we are considering the basic features, and from these basic features, basically with linear combination of the weights, you can say theta can be categorized as a weight parameters, and provide some kind of an activation function such that J represents the layer that in neurons first category comes from the first layer, where the cell body analyzes the inputs. It is the second layer, or you can say that is the activation function. So in this activation function, index follow. J is also categorized 1, 2, 3. So similarly, I index 1, 2, 3, and this activation cell can be more than one. And from this activation cell, with the help of logic gates, AND gate, NOT gate, NOR gate, we are getting the conclusion remarks in form of the required output. And this is the final decision that is neural network done. So once the input features perform the linear combination with the weight parameter, basically we are getting some kind of a formation in form of theta transpose x. This is basically hypothesis function, and this is equivalent to, and this hypothesis function further provide the activation layer, as I already told you that it can be more than one. So how mathematically it performed? As we can understand that theta transpose, these is the weight values with features can be transformed in form of, for example, the first weight parameter, second weight parameter, third weight. Okay, this is the benchmark weight parameter. These are kind of a biased value, and theta 1, theta 2, and theta 3 are the determined weight parameters, or you can say derived from the first initial biased value and multiplied with features x0, x1, x2, x3. In a conclusion remarks, we can write theta naught x naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3. Where usually we are talking about the x naught thing, it's equal to 1. That is the unique thing in itself. So once we got this hypothesis function, we can apply different kind of application, or you can say that the cell body on it, and here activation function is kind of a sigmoid function that is further performed on this weight parameter, this hypothesis function. The sigmoid value can be determined with this formulae, and this output 0 and 1. So, and we are getting a behavior of this in form of this, okay, minimum 0, maximum 1. So somewhere in center it's the 0.5. So this sigmoid function help out to analyze the final decision in terms of the neural network. Wait, remember that if we are talking about the weight from the first layer, if we are considering the three features x1, x2, x3, and there is activation cell A, that is the J, and here I. If we are considering the first activation cell, weight, okay, for initial one is the benchmark feature, and of course benchmark feature is having some kind of a weight, theta naught, and then from the other case we are getting another weight. So once all will be summed up, as I already explained here, summed up, all will be summed up and give up some kind of combine this hypothesis function, and this hypothesis function further can be analyzed in terms of sigmoid function, and sigmoid function will give us some kind of a decision boundary, and we are getting some kind of hypothesis output. One more thing, at this point, remember at this point, this is okay, sum of all features in terms of linear combination with the weight value, then analyzed here, okay, as a cell body analysis done with the help of sigmoid function, and this is the final output. Remember, weight can be of any nature. For example, if we are considering the 4 different weights, it can be -1, 1, 1, 1. Yes, it can be whatsoever, -10, 20, 20, or 30, whatsoever. This further different category of the weight parameters can be considered. Moreover, in some cases, neural network perform different applications for different robotics and different machine learning algorithms. Sometimes we need to use the AND gate. If we need to consider the circuit in series. If we want to glow the bulb, then of course we need to connect both the points in order to flow of current. So AND gate is required, and here our final output decision boundary will provide the 2 output. Sometimes we need to consider the OR gate, where we need to consider the circuit in parallel. So if on any one point can be connected, then electric current will flow. So only single decision is enough in order to get the required output. OR gate is enough. That is kind of a true or false whatsoever. Sometimes we need to utilize the combination of AND along with negation of AND gate. So that we should do this task or we should do not do this task. For example, if some robot need to apply missile launching or do not launch depending upon certain parameters. So this all help out in order to analyze if, for example, 2 features are meeting the criteria, then missile will be launched. In this situation, 2 outputs are required, so we can use the combination of the logic gates in order to get the final decision. Moreover, once we are considering the neural network by following the neuron concept, suppose this is the first layer, and okay, let's we consider the 2 activation cell. First one is this one. This is the first activation cell, and the second one is this one. So here how we can get the weight combination from this input features. This is the first layer, and the weight from the first layer to the first activation cell can be expressed in form of this, and we know the four weight parameters: the first one, the second one, the third one, and the fourth one, started from the benchmark weight, initial weight, and third one. So now remember, this first weight comes from the first layer, so index will numerator or top index will be expressed like this, and it is going to the first activation cell. So here in the first layer, and it is going to the first activation cell. So in the sub index it represents as 1. So in expression it will give us the, and if we are expressing this in form of sigmoid function, we can express like x naught 1, 2, 3. So this is the summation, okay, and give us some kind of activation, and of the sigmoid function. If we are talking about the activation of the second cell, then we will express this. Again, we know the weight values. But it, again, we also know that it comes from the first layer. But it is going to the second activation cell. So here we need to mention, or you can say sigmoid function can be expressed in form of this for the second activation cell. So we can get the different activation cell